Glass has shaped the way we experience architecture for centuries, from ancient craftsmanship and stained cathedrals to modern skylines and transparent facades. But beyond its visual appeal lies a deeper story of material innovation, geography, culture, and technology. In this episode, architect Anuja Sawant, principal architect at SSA and IGBC Accredited Professional, explores the history and evolution of glass, tracing its journey across civilizations in India and beyond, while unpacking its manufacturing processes, properties, types, applications, and the ongoing debates surrounding its role in contemporary architecture.
Glass as a subject because as a practicing architect, we are working very closely with this material, extremely versatile material. For past 3 decades, glass is being extremely popular. And as we are working largely on the high rises, it becomes an inevitable material as it's, I would call it as a skin of our buildings. So it's very important that when we are handling such materials to understand the properties of the material, upgrade the knowledge of upcoming new product because it's a technology oriented. So every time we see a lot of new trends coming into the market, and as a practicing architect, as I mentioned, we have to upgrade ourselves and keep with the current trends. 3500 BC, where the archaeological evidence shows that the first glass was made in Egypt and the eastern Mesopotamia. There were small artifacts like amulets and the pearls which were made with the clay molds. In this period, first manuals on the glass manufacturing processes appear in 650 BC. In 1500 BC, the first glass vessels appear. And in 100 BC, the Sirius invented the blowpipe, revolutionizing the glass manufacturing process and making it more and more easier and faster and cheaper. After that, the glass production started in the Roman Empire. So you could see these elements where the glass was introduced in the historic period. What happened in the 8th century? 8th century, what you could see that the Venice receives the craftsman flame from the Constantinople and becomes a great European glass making center. Throughout Europe, the art of making stained glass windows in churches and cathedrals has a widespread. And when we go to all these European places, it's a splendid places where we go, and it's mesmerizing experience to see all these stained glass details into all those churches. In AD 100, what you could see, the Roman began to use of glass for the architectural purposes after discovering the technique of the flat and transparent glass. The molten glass windows, although poor in the optical quality, began to appear in the most of the important places in the room. A cheap technique of production of a flat glass, blown glass, or the furnace rotation resulted in a circular glass plate, finer at the tips and the thick center. The thickest part was used to make the chipper windows, and the thinnest were observed as expensive windows. So that was a trend, and the costing was decided based upon the thickness of the glass. At the same time, the Romans also invented the mirrors. 16th century, where the manufacturers of glass extend in the France, England, and Germany, and various techniques were perfected. Larger flat panels with a smoother and more homogeneous surfaces were formed. You can see those evidences in palaces, and the Garden of Versailles are the greatest exponent in which the glass was used, and glass used in the manufacture of fine tableware during the 17th century. With the founding of the British Plate Glass Company, England became the world's center of the window glass, and for the first time in the history, window glass is accessible to the large part of the population. In the 19th century, the Industrial Revolution in the glass, where iron and glass were blended together and had become a great novelty of the modern architecture. And that's where in 1851, we could see the Crystal Palace was built entirely with these two materials. And that's where I think the engineers and architects brought real revolution, where when you go and visit, you can see that it's a true romance of a glass and the steel or the iron was done in the 19th century. Once we come to the 20th century, in 1950, the float glass was created by the British Alastair Pilkington, and you could see that the Walter Gropius and the Mies van der Rohe using them more into the straight lines and creating a different kind of an impact with this material and gaining a lot of transparency into the architecture. In 21st century, the glass industry has become a global industry as the patent of the Pilkington process expired and the cost have a glass factory were drastically reduced, and today we can find them around the world. So this was the revolution age where the glass had become a very popular material. Let's see what happened in India. In India, the development of a glass technology in South Asia may have begun in 1730. Evidence of this culture includes the red brown glass bead along with the beads of dating to this period and making it earliest attested glass from the Indus Valley. So we could see those evidences in 600 and 300 BC. Since prehistoric period, people of Mohenjo-daro and Harappa, through the trade and the contacts with the ancient summer fusion glass, etc., Firozabad is a glass city of India and started the production of a glass back in 17th century. And the research says that the first glass plant was set up in August 1908 by Lokmanya Bal Gangadhar Tilak somewhere in Talegaon. So this was something which I found in the research. Very interesting fact. So what happened in the Indian context, if you'll see that in Mysore Palace, you can extensively see the use of a stained glass which has been done, and you can see more Indianized motifs of the flowers ornamentation seen in the Mysore Palace. Whereas in Mysore Palace, there is a complete hall of mirror. So you can see a lot of Bing happening in the Indian context. And City Palace of Udaipur completed in the 16th century, or the Sheesh Mahal, are few of the examples where the architecture is the mirror of life. That's where the history ends. And we begin with the new era. So anil glass is a clear glass, tinted glass, or the frost glass. Anil glass is formed from the annealing stage of the float process. So the molten glass is allowed to cool and in a controlled way until it reaches to room temperature and relieving any internal stresses in the glass. Anil glass is used as a base product. So it's a basic glass, and anil glass tends to break with the longer or the jag shards, which can cause a significant injury. Now, processed glass are the laminated glass, tempered glass, and the fire-resistant glass, smart glass, retrofitting glass. So processed glass is made by subjecting anil or the float glass to thermal or the chemical treatment in order to change its property. So various techniques are available in the market by which the brittle nature of a glass is modified, and it is made as a very strong or material which has a strength into it. And because of the height or the wind pressure, it is very important that that material can become a structural material where you can utilize them in the adverse condition. So that's how now the glasses are processed, and these various kind of glasses are used in actual construction industry. So laminated glass. Now, what are the properties of the laminated glass? So laminated glass is manufactured by sandwiching a layer of plastic such as PVB in between two sheets of glass, and this insulated layer makes the glass impact resistance and the sound resistance. Laminated glass upon the breakage remains intact as a broken piece stick to the interlayer. Tempered glass is a glass of the toughened glass and is formed by heating annealed glass in order to develop opposite stresses on its surface, and this makes the toughened glass much stronger than the regular glass. So in the construction industry, you will see the use of a tempered glass, or you will see the use of a laminated glass from the safety perspective. So the picture itself shows that when they are going to break, they are not going to make any sort of injuries wherever you are using them. So whether you are using them in the residential context or you are going to use them in the commercial places. So now the uses are defined as per the application or the type of the building. The glasses are picked and choices are being made. Now, very important aspect is a fire resistance glass. So what happens in case of the fire resistance glass? Now, these glasses are not much used in the facades. In a very strategic areas, it is used as an exterior material, but you will see them as maybe probably used for the data centers, or maybe use them as internal partitions, or they are some places used as a vision panel. So these are the glass which is multi-laminated glass, and they are intumescence layer which can withstand the extreme level of heat, smokes, and the flames. So based upon the National Building Code and the fire rating, the thicknesses ranges from the 7 mm to 20 mm to 30 mm. Definitely the cost will also go higher. When you are using this fire glass, the entire assembly would have the rating. So it's not just the glass who is going to perform, but each and every element of this framework has to perform with the fire resistance. So it's very important that the entire assembly needs to be tested when it is to be used as a fire resistance glass. Smart glass. So smart glass is a type of a glass that switches its optical transmission properties due to the passage of current, and thus the glass can change from the transparent to translucent and vice versa. So more you can see the interior application, where as per the usability, you can utilize this glass in a peculiar fashion. They have certain spans where you would need a structural members to support them or fit them, or certain hardwares are available where by which you can use this glass. Retrofitting glass is a type of a glass which has a low E interlayer and is applied above the old windows in order to make them more energy efficient. So in case in your energy simulation there is large amount of heat gain, or your visual light transmission is not appropriate, then you can think about this as a solution. So retrofitting can happen. Maybe it's a heritage structure or something like that, and there these kind of glass can be utilized. So these kind of options are also available. So what it shows that you classify the building, you understand the type of a building, and you can pick and choose this particular material. There are new trends, as I said, that in the past history you could see the kind of a stained glass which is more ornamental. Now the glasses are coming as a ceramic frit or dichoric glasses, which can have that kind of a ornamentation and new age technology where you can blend them into your architecture and use them very wisely as per your design. So what is dichoric glass? This glass was originally created by adding a trace amount of gold and silver to large volume. The resulting medium partially reflects the glass passing through it and causing an observer to see a different colors depending on the direction of the light source. So this can be used by using the titanium, zirconium, and vaporization kind of a technology. The vapor then condenses on the surface of the glass and it forms a crystal structure, and a protective layer of a quartz crystal is sometimes added, and other variants of such vapor depositions or PVD coating are also possible. So this is going to give you some sort of a different effect on your surfaces. Probably you can use them in the interiors, probably you can use them in the exteriors, looking at overall application, and create very interesting features to your buildings. I'm just showing an image which making it look very interesting. So usage of a dichoric glass in an office building. So very playfulness, you can get it into your interior spaces, and the large span. So can be thought about this kind of material. Then you can see the ceramic fritting. As I said that the ornamentation. Now these ornamentation can be brought by creating a kind of a motif, and that motif, ornamented motif, can be utilized on the entire facade, and by which you can make it look more softer look can be brought. Back painted colored glasses can be used. Any kind of patterns can be created over the glass, and it makes it look more seamless, more interesting in the new age technology. So ceramic fritting is one more option by which you can have a silk screen kind of a printing to be done on the glass. So what are the pros and cons? So it comes to the pros and cons of the material. So let's first understand the pros of the material. So it's a lighter building material. That's why it is used for the high rises. It blends with the exterior and interiors. Ease in installation. Flexible building material. Very strong material. It has its strength. Aids in urban monetization. Of course, it's a faster product, available, very much possible, easily to implement, to construct, and recyclable. Of course, that's a very important aspect in the today's scenario, that whatever material we are recommending, it has to have that kind of a recycled content to make it more and more green. So what are the cons? Glare. If you don't choose the right kind of a glass or right percentage of a glass, then we have to face the glare. Heat island effect, as I said, that the reflecting too much of sun, and that disturbing the surrounding development. Then the privacy, kind of a glass, if more of reflecting, same way you are going to get the reverse reaction at night. So it could impact your privacy. Safety parameters, if the recommendation is not done properly, where the laminator needs to be used, if you go with the tempered glass or the toughened glass, then the safety could be the issue. Impact needs to be understood. Maintenance, if these materials are not maintained properly, your facades are not maintained properly, then it's going to create that kind of non-maintained urban scenarios which are going to happen. And the construction tolerances, which is another issue what we see when we are actually implementing, that could create some sort of a cracking or not having the even surfaces or leakages, or these are the issues. This is a residential towers which are in Wadala, ICC towers, which is almost 30 lakh square feet of a construction. And one ICC 1 tower is 51 storied and ICC 2 is 58 storied tower. Now this was the building where the complete unitized system was implemented. As there were no decks, the complete window system was the unitized system, and this kind of a high rise, that's the best solution. So this is how these two towers are completed right now. So on the left hand side, you can see the completed picture, and on the right hand side, it's a 3D view. The picture of the project handed over and occupied. This is a typical bedroom where you could see in the unitized system, what you can see is that there is a cross ventilation given, but the windows are push type, as these were all air conditioned apartment. You could see from the safety perspective, only 15 degrees of angle has been given, and all the other windows are having the aluminum framing and they are fixed windows. So these are all single glazed unit, but while selecting the glass, are in, are out, the U values, the VLT were all analyzed by the energy simulation, and the right kind of glass were chosen. So this is how the unitized system, where you're, I'm going to show you the detail how the unitized systems working in the residential context. It's a wonderful solution where you, it blends wonderfully while constructing. So when we are coming up with within your bylaws where there are no balconies or no decks, but for the high-rise building where there's kind of a flat slab construction or the PT slab kind of technology, there these kind of a unitized system are the faster. In case of unitized system, there's a lot of work which is done off-site, and that's why it rapidly gives you the results where you can really go fast in your construction. Your tolerances can be looked into it properly. So this is what I would say the best solution for the high rises, whether it's a commercial or even the residential. So all these details can be well worked out and can be executed. So we got a wonderful results for this project, I must say. Glass. As we all understand, it's a very versatile material. There are new trends coming into it. One has to understand the detail, one has to understand the application, one has to understand the usability. And while studying, carefully studying of all the aspect of sustainability, the properties of glass, carefully we can choose the glass, along with that the frame, along with the hardware, and of course the cost and the construction tolerances, we can come to the final solution. But what is the future of glass? there are few new trends coming into the glass. So I just want to take you through them. So what is called as a media facade? So what is a media facade? So media facades are the layer of individually controlled lights attached or even woven into the exterior surface of a building to function as a dynamic palette for the text, graphics, and video animation. When design media facade opportunities to push the boundaries are myriad, encouraging lighting designers and architects to embrace the new language and explore the use of light and media as a facade material to form an integral part of architectural region. Is extremely vibrant, interactive, and creative. So it's absolutely new age, and as I said, vibrant, and for the younger generation, something to celebrate. So harnessing the solar energy, you can integrate your solar panels. So this is a future of glass, because this is something which is amply available to us. How we are integrating into our facade and how we are integrating in our buildings are very important. Recycling is very important. So whatever material other than glass, whatever material, we really need to understand the recycled content of that material. So I'm going to close down today's my presentation. It was a very long presentation, and I've tried level best from my side to understand while going through this presentation. I could do a lot of research. I'm sure you all must be having so many questions. So I'm going to open this discussion for the questions. So before leaving you all with my presentation, I just want to leave with one quote from architect Zaha Hadid, that there are 360 degrees, so why stick to one? So this is what I would like to say, that it's a clear solution, it's a best material, but at the same time, one has to be very sure, very confident, and very much updated with the new age technology and embrace this fantastic material. So thank you to you all. Thank you for your all the patience and time. Once again, let me say that stay safe and stay at home. Thank you. Thank you so much.